All right, so we can see the problem here. It's kind of hard to see the whole thing because I've got my calculator over here to the side. Let's see if I can make it a little smaller again. A little bit smaller even. All right, Bob owns a watch repair shop. He has found that the cost of repairing his shop, or operating his shop rather, is given by C of x equals 4x squared minus 312x plus 45, where C is the cost and x is the number of watches repaired. How many watches must he repair to have the lowest cost? All right, notice that we have a quadratic equation here. Whenever you have a quadratic equation, you must remember that in order to figure out a maximum or a minimum number of watches, the maximum height a ball goes or a projectile flows, we need to know the axis of symmetry. We need to know the x-coordinate of the vertex. And to find that, we use this formula. This is one that really needs to be in your memory. The opposite of b over 2a. Now, where in the world is this b and a coming from? It comes from the quadratic equation that we have. So let's identify the parts that are a, b, and c, and then get to solving this problem. All right, so in this equation, remember that the quadratic, general form is ax squared plus bx plus c. With that being said, it should be very easy to identify these individual parts. So a is definitely going to be 4. B is going to be negative 312. And c is going to be 45. Now let's move on and find our axis of symmetry, or our x-coordinate of the vertex. It's funny in math that we have different names that deal with the same thing. The axis of symmetry is that imaginary vertical line that cuts the parabola in half, and that vertical line goes to the x-coordinate of the vertex, so they are the same value. Weird, but important. The opposite of b is a positive 312 divided by 2 times 4, or 8. Once we divide this number, we will have found x, and x is the number of watches that are repaired. And the question was, how many watches must he repair? So when we find this answer, we're done. Let's go over here to our calculator and see if we can calculate that. All right, so let's get down with our bad cells and put a 312 divided by 8. 39. So in order to have the lowest cost, Bob needs to repair 39 watches. And that's all there is to that. Get that formula down, very important. On to number 14. So we're going to use the square root property to solve this quadratic. 5x squared minus 2, 5x minus 2 quantity squared equals 2. When it's in this form where the squared is on the left or the right and the number is on this side, it is best to use the square root property. And this is how you use it. You put a square root on each side of the equation. Now when you solve this left side, the square root actually de-squares the problem, if you will, and leaves you with 5x minus 2. Goody goody gumdrops. This is going to equal, now this is the part that folks forget. When you take the square root of 2, you need to write plus or minus 2. Because remember, we're dealing with the fact that when you take the square root of a number, it could be positive or negative. Negative 2 squared is 4, positive 2 squared is 4. So you got to do plus or minus. Now the next step, since we're solving for x, is to move this 2 over to this side of the equation. So we get 5x is equal to, now to move that 2, since it's being subtracted, we're going to add it. So you're going to add 2 to the other side. So that becomes 2 plus or minus the square root of 2. Now it's really up to you where you put the 2. I like to put the 2 in the front. If you want to put it in the back, it just looks a little strange to me, but you can put it there. And then we're going to divide by 5. And Pearson will accept it as well wherever you put it, as long as you don't put it under the radical with the other 2. So our final answer looks like we solved this problem using the quadratic formula, but we didn't. It's 2 plus or minus the square root of 2 over 5. Now you can write that separately or together. It's entirely up to you. Complete and correct. Moving on to number 15. Evaluate the discriminant and predict the type and number of solutions. All right, I'm going to move this over a little bit so I can have a little bit more space to move and to talk. Now, what is the discriminant? I hope that you remember the discriminant to be the actual expression underneath the radical in the quadratic formula. B squared minus 4 times A times C. And remember that the general form of a quadratic looks like ax squared plus bx plus c. And notice that I put the colors to correlate with the actual plugging in. The B is blue, the A is green, the C is red. See how I color coordinated that for you? Now let's evaluate what the discriminant actually is in this case. So in our case, the B is 14. So we're going to write, let me use a little thin pen here, 14 squared minus 4 times 1, because there's a 1 in front of that t squared, so 1 times 49. And I've got the smallest sinkingest feeling that 4 times 49 is the same thing as 14 squared, but let's confirm it over here in the calculator. So 14, let me come over and make the calculator a little bigger. It got scared. 14 squared minus 4 times 1 times 49. When you are calculating under the radical, go ahead and put the whole thing in your calculator. And maybe even put the radical part, but I'm just going to do this part just to get the value here, and it's 0. Now we have to remember the different types of solutions and things that happen when our discriminant equals certain things. So what happens when our discriminant equals 0? Let's review all the things that could happen. These are the solution types, and this is what happens when. So you get one real rational solution when the discriminant equals 0. So we know that we have one real rational solution. Now in your book, it doesn't stress the idea of it being rational, but it is because you can write it as a fraction. You get two real rational solutions if it's a positive perfect square. So if you got 4, 9, 16, 25, you know, the typical perfect squares, then you're going to get two real rational solutions because you can actually take the square root of 4, 16, 25, 36. You get two real irrational solutions if it's a positive non-perfect square, like the square root of 3, or the square root of 7, or the square root of 11. Because we don't know those things. Only the calculator knows that. And then you get two non-real complex solutions if your discriminant is less than 0 or negative. So we've evaluated the discriminant, and we predicted that we're going to have one real rational solution. Now, usually Pearson asks for one more step. It would actually ask you to solve this problem. So since you've evaluated the discriminant, we might as well go ahead and find out what it's going to be. So we use the quadratic formula, which is the opposite of b, negative 14, plus or minus the square root of the discriminant, which we now know is 0, divided by 2 times a, which is 2. So our answer is going to be negative 14 divided by 2, or negative 7. So once you evaluate the discriminant, using the quadratic formula is oh so easy. So definitely do that. Let's move on to number 6.